This is Srikanth, working as HTML professor in electrical department. In this video, I want to discuss about overview of network topology or graph theory as well as two-port network. So here we have some topics. Two-port parameters. So in general, two-port parameters means ABCD parameters, Z parameters, Y parameters, and hybrid parameters. Impedance parameters, admittance parameters, transmission line parameters, as well as hybrid H parameters, and their internal relationship. So if I know the one parameter, I can find out the remaining parameter. And we have one more. Suppose two-port network connected in series. What is the answer? Two-port network connected in parallel. What is the answer? Two-port network connected in single line. What is the answer? Okay. So their interconnections. And we have one more topic, that is network topology. In that we have incident matrix, basic tie set matrix, basic cut set matrix, as well as duality, network duality. So we'll check it one by one now. So coming to two-port networks. So two ports, we have two ports, primary side voltage and secondary side voltage, primary side current and secondary side current. If you observe the two-port network, we have four terminals. So four terminals. So if I find out the impedance or admittance or any gain values using four terminals. So primary voltage, secondary voltage, primary current, and secondary current. So these four parameters, using these four parameters, we can find out the impedance values, admittance values, and gain values. We will check it one by one in this two-port network. Now coming to Z parameters, we have equations V1 and V2 in form of I1 and I2. Like admittance, Y parameters, currents I1 and I2 in form of V1 and V2. Coming to ABCD parameters, V1 and I1. So input values V1 and I1 in form of V2 and I2. H parameters, hybrid parameters, hybrid. So V1 and I2, hybrid. Primary voltage, secondary current in form of I1, V2, I1. If you know this, like equation and which form. So Z parameters, Y parameters, H parameters, like two-port parameters. It's very, very simple. If you know the equations, then the two-port networks, it's very, very simple. You will get like by out of by marks. Okay. Now, from this formation, we have the equations. So, like V1, V2 in form of I1, I2. That is Z parameters. So, Z parameters means we have the four terminals. So, we have the four values. So, Z11, Z12, Z21, Z22 values. Coming to Y parameters, we have I1, I2 in form of V1, V2. Again, Y11, Y12, Y21, Y22. And same thing, ABCD parameters, V1, I1 in form of V2, I2 and A, B, C, D we have. And why this minus? So, coming to transmission line parameters, in transmission line, the current direction need to like this. But your two-port network, so I1 current is and I2 current. Just observe both currents here. So both current is reverse direction. So we have the I2 value is 0. I2 value is minus. So reverse. When you are coming to transmission line parameters only. Okay. And H, suppose your currents are direction, both are in same direction, will take like plus values. No need to worry about the direction. Direction means it's like sign. That's it. Value is same. A value, B value, C value, D value is same as it is. And coming to H parameters, V1, I2 in form of I1 and V2. Here H11, H12, H21, H22. Now, this is about the equation coming to. I want to find out the impedance values like Z11, Z21, Z22, Z21. For this, you can use, so any circuit, suppose here I have like this circuit. Okay. So here I have V1, V2, I1, I2 values. Now, on find out the impedance values Z11, Z22. So for this, so from this equation, if you can write those two equations, then compare those equations and get the answers. Otherwise, if you know the conditions, suppose here I2 value is 0. I2 value is 0. So this whole is 0. I2 value is 0. Then your Z12, Z22 value is 0. So then you can find out the Z11 value. Z11 value is V1 by I1. Z21 value is V2 by I1. So this is one condition when I2 is 0. Same I1 is 0 now. Then I can find out Z12 value, Z22 values. So Z12 is V1 by I2 and Z22 is V2 by I2. Same as each conditions. So each impedance, each parameters. So here we have I1 equal 0 one condition, I2 equal 0 second condition. And coming to Y parameters, V1 equal 0 and V2 equal 0. And coming to ABCD parameters, V2 equal 0 and I2 equal 0. And coming to H parameters, we have I1 equal to 0 and V2 equal 0. If you compare all equal zeros, here I1 is there, here I1 is there. And here I2 is there, here I2 is there. Here V2, same V2. And we have a V1 also is there. So total 4 conditions. So that is primary side, which you have two pole network. So primary side voltage 0 and secondary side voltage 0. Primary side current is 0, secondary side current. If you know the 4 condition, you will get the all parameters. Okay. Now suppose here I1 equal 0 means, so any circuit, the primary side I1 is 0 means it's open circuit. So primary side is open. Coming to I2 equal 0 means secondary side is open. So any circuit, just consider any circuit. So we need to consider only primary side. Second side is open means it's 0. Same thing here, I1 is 0 means primary side is no need to consider. We need to consider only second side. And V1 equal 0 means primary side is short circuit. So any circuit, you consider any circuit, here you have T-type network. So primary side is short circuit. And find out the which value you want. I1 value, I2 value and V2 values. Remaining values. And same thing, V2 equal 0 means now here's a V2 value. Now V2 equal 0 means same T network. Here second side is short circuit. Here I have a V1 value. Again find out the remaining values. So when one parameter is 0 means you need to find out the remaining parameters. Clear guys? So suppose I1 equal to 0 means, so primary side is open. So we need to find out the I2 value, V2 value and V1 value. And find out the which impedance you want, which admittance you want, which gain you want. And same thing, I2 equal 0 means we need to find out the I1 value, V1 value and V2 value. V1 equal 0 means we need to find out the I1, I2 and V2. V2 equal 0 means we have I1, I2 and V1 values. We need to find out the remaining values. And find out the gain values. If you want the gain values, impedance values. Okay guys, this is about the 2-port parameters and find out the formation and equation. And coming to like a internal relationship. If I know the one value, I can find out the remaining value. If you observe here, before moving to internal relationship, if I observe the Y parameters, so Z parameters and ABCD parameters. Suppose Z parameters and ABCD parameters. Here I have the V2 value in form of I1 and I2. V2 value in form of I1 I2. So from this equation, if I want I1 value, so I1 Z, suppose Z2 Z21 I1 is equal to V2 minus Z22 I2. Am I right? From this equation, observe clearly, we'll get the answer. So I1 is equal to V2 by Z21 minus Z22 by Z21 I2. Now your I1 in form of V2 and I2. Observe now, I1 in form of V2 and I2. So this is your 1 by Z21 is your C value. 1 Z22 by Z21 is your D value. So like that we can find out that if you know the one parameter, I can find the remaining parameters. So they internal relationship. Suppose I know the Z parameters. If I know the Z parameters, I can find out the Y parameters, ABCD parameters, and H parameter. If I know the Z parameters. So these formulas using those equation, if you compare two equation, Y parameter equation as well as H parameter equations, we will get like these formulas. Same ABCD parameters as well as H parameters. And coming to Y parameters, if I know the Y parameters, I can find out the H parameters. So Z parameters, ABCD parameters, and H parameters. If I know the ABCD parameters, I can find out the Z. So observe clearly. So if you know the one parameters, I can find out the remaining parameters and the values, which values we have. If you observe clearly, so everything is different, not same. Okay. So if I know the ABCD parameters, I can find out Z parameters, Y parameters, and H parameters. If I know the H parameters, I can find out the remaining parameters. Okay. So these are the internal connections. So the connection is when you know the equations, it's very simple. If you don't know the equation, it's difficult. Okay. And here we have one more topic, that is interconnections. So when the two port networks connected in series, then what is the answer? So which parameters I need to add? And when two port networks connected in parallel, which parameter I need to add? And when two port networks connected in one line, then what is your value? So for here I have two port networks connected in series. So I will select series. Series means suppose positive, negative, again positive, negative. This is in series. So first point and second point, both are connected in one place. Now here we have the positive value and negative value and positive value, negative value. Same thing. Second side positive, negative, and positive, negative. So primary side positive. So where we have the primary side, the positive and negative connected to one point. So positive and negative connected in one point. So both are in series. So primary side connected positive, negative, and second side positive, negative. Now I need to find out the equal value. So when two are networks, two port network series means we have the formula. Generally we have two resistors we have. So R1 plus R2, both are connected in series means R1 plus R2 in general. But here two port networks connected in series. Then so in series resistors, what is the same? In series resistor, currents are same. So which current we have here? Same current here. So which current we have here? Same current here. So that means voltage are different. So voltage drop here different, voltage drop here different. So we require the voltage equation. So voltage equations means V1 and V2, which equals we have in Z parameters. So when current is same, we need to go for the Z parameters. So here I will find out the V1 and V2, I2 as well as I1 value in form of I1 and I2. So in that, for this parameters, P parameters, I want Z equation, and Y network I want Z equation. So this is P network and the S network values. So in P network, Z11 or P in form of that P value. So that P network value. Same Z12 and P network current in form of I1 and I2, I1, I2 of P network. Same I1 and I2, I1 and I2 of S network. Now we need to add those values. Series means the current is same. So which current we have? Same current here. So we need to add those values. So I is I1. So V1 and V2. V1 and V2 in form of I1 and I2. I1 and I2. So here we have Z1, Z11 of P and Z11 of S. So we need to add both two impedance. Here also 1 2 1 2, 2 1 2 1, 2 2 2 2 2. So we need to use the Z parameters and we need to add those values. Coming to parallel case. So when you have the parallel, we have voltage are same. So voltage are same, current is different. So we need to find out the I1 and I2 values. So I1 and I2 means I need to go for the Y parameters. So when the parallel means, so positive, negative connected. So positive connected one place and negative connected one place. So here positive, negative and positive, negative. So positive connected one place and negative connected one place. So observe clearly, you will get the answer. So primary side and second side, positive connected one place and say negative connected one place. So that means P network and S network both are connected in parallel. So both are connected parallel means I need to go for the Y parameters. So in Y parameters means your I1 and I2 in form of V1 and V2. Write the equation for P network as well as S network. Then add those voltages. So this voltage and this voltage. So P network Y1 value and Y network your Y1 value. Add those values. So parallel means we need to go for the Y parameters. Series means we need to go for the Z parameters. Then both are connected to one line. Then which parameter I need to use? So one line means transmission line parameters. So here we have the transmission line parameters. So both are connected in line. So we need to go for transmission line parameters. If you observe the current directions, both are reverse. So when you have the current direction, both are reverse. We need to go for the ABCD parameters. So transmission line parameter means ABCD line parameters. So write the equation for P network as well as S network of ABCD parameters, and for series we added those current values. In parallel we added the admittance values. Coming to in single and cascade, you can select cascade network. For cascade we need to multiply those values. So the voltage values we need to multiply and current value also need to multiply. So here A of P and A of S in multiple position. When you have the transmission parameters, so we have the primary and secondary. So primary and secondary. So we have like primary voltage and primary current. So in form of secondaries. But here we need to multiply those values. For series we have the current we need to add, and parallel we need to add voltage values. Coming to cascade, we need to multiply those voltage and current values. Okay, this is about internal relationship. Coming to next, equivalent circuits. So for two-pole network, we have the equivalent circuits. Okay, now for Z parameters, so I will explain one. So remaining is as it is. For Z parameters, Z11 I1 plus Z12 I2 and Z21 I1 plus Z22 I2. So these are equation. So I1 and I2 in form of like V1 and V2 in form of I1 and I2. So these two equation. Now for Z parameters, what is the equivalent value? Y parameters, what is the equivalent circuit? And ABCD parameter, what is the equivalent circuit, as well as H parameter, what is the equivalent circuit? Now for two equation, from these two equation, I will go for the equivalent circuit means. So if you observe the equation number 1, so equation number 1, here I have voltages. So this is also voltage and this is also voltage. So V1, here I1 and I2. So V1 is voltage, so primary current. Here V1 voltage but secondary current. So if suppose I have a closed loop, so in this we have two impedances, so Z11 and Z12. In a closed loop I have two impedances, Z11 and Z12. For Z11, which current we have? Only I1 current. So here primary means V1 voltage, I1 current. It's okay for us. Coming to Z12 we have I2 current. So this voltage, which voltage we have, is depending upon I2 current. So that is different loop current. Here first Z11 means we have the I1 current, no need to worry about the I1 current. So we have the same loop, we have same voltage, we have no problem. Coming to Z12 we have I2 current. So that is, here we have the voltage dependent, like a current dependent voltage source. So dependent source we have, that is current dependent. So that is I2 current. So here we have Z12 is as it is, but Z11 is as it is, Z12 is dependent current source. That is your I2 current. That I2 current is secondary side current. So this is from equation number 1 circuit. And coming to equation number 2, same. We have V2 and V2. So V2 we have and I2 we have. So V2, I2. So secondary side. So that Z22 value we know. Z21 value is depending upon your I1 current. So Z21 depending upon your I1 current. If you write the equation, loop equation, we have from this two circuit. So from this circuit, you want to write the equation means we will get like two equations. So same as your Y parameters. So your I1 and V1. I1 and V1 means I1 by V1. So admittance value. Am I right? Not impedance, admittance. That means parallel value. And here V2. Now your current source is depending upon voltage. So here we have the voltage source. But here we have the current source. Current source means again dependent source with current. But the current source depending upon your voltage V2 value. Same here we have second equation like a Y22 admittance, and Y21 is depending upon your primary voltage. Coming to ABCD parameters, here voltage. So here coming to ABCD parameters, we have the voltage. Okay, here I is some impedance admittance into voltage, some admittance into voltage. So okay, no problem. Coming to V1, some value into your voltage. Again, which voltage? Secondary voltage. Coming to B value also with secondary current. So both are dependent sources. Coming to Z and Y parameters. So not dependent sources. One is like independent sources. One is dependent sources. So we have some circuit. Coming to here, both are dependent sources. Equation number 1 and equation number 2 both are dependent sources. So no need to write we don't have any equation circuit for this ABCD parameters. Coming to H parameters, again we have voltage. So this is like current independent. So V1, I1. We have the current independent means Z11, H11 value we know. And here we have voltage source. Here also voltage but V2 voltage. So your V1 source is depending upon your V2. So we have here voltage source, not current source. Here voltage source depending upon again, not current, depending upon voltage. Comparing with the H parameters, here we have like a voltage source but depending upon current. Here we have the voltage source but depending upon voltage, V2 voltage. And coming to equation number 2, we have the current sources. So here we have the current H11 and current. So H11 is there. Coming to second equation, your I2 as well as V2. So we have the admittance. So that admittance value. So I2 by V2 has admittance H22 value. And coming to one more. So here I2 current and here we have I1 current. So depending upon current. So we have the current source depending upon one more current. Here with a current source depending upon the voltage. Coming to Y parameters. Here we have the current source depending upon current. So same as your Z and Y parameters. Okay. So here this is the first part and this is the second part. This is like a Z parameters and Y parameters. Okay. But here we have the current source, but here we have the voltage source. Here we have the voltage source, but here we have the current source. That's the difference. Okay. So this is about like a 2-port networks. And we have one more topic, that is graph theory. So coming to graph theory, we need to know the nodes and branches. For network topology or graph theory, we require the number of branches, number of nodes. So any circuit converted to with lines. So voltage source or current source or resistor, impedance, so capacitor, anything replaced with single line. Okay. So how it is means, suppose here I have the voltage source and resistors I have, and on current source also I have. So for this network, your graph theory or network topology is, so resistors or inductor, passive elements. So passive elements replace with line, single line, and sources, voltage sources short circuit, current sources open circuit, as it is. Okay, so here I have the resistor R1, R2, R3, R4. So R1, R2, R3, R4. So 4 lines. So we have the 4 resistor, 4 lines, and voltage source is short circuit, and current source is open circuit. And coming to, so this is a simple method, but here the main problem is we need to identify the number of nodes, number of branches. That is the main problem. So in general, I have a circuit like this: resistor, 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 resistor. Just observe clearly, guys. I have a voltage source and resistor, and same thing, resistor here, resistor, resistor. Some small circuit. So for this circuit, I want to find out the number of nodes. So what is your number of nodes means? One node is enough. So when you're writing the graph theory, so this is the main important. So here we need to go for the, but each element lines. So each element convert into line. So that means we need to go for the each point and find out the nodes. So each point. So here the resistor I have. So here for this resistor we have this one is 1 point and this is also 1 point. For this resistor we have 1 point and this is also 1 point. So each element we will find out the nodes. This one. So in general we can select only V1 node. So only one node, and you can find out the current values in general. But coming to graph theory, we need to go for the each places. Each places we need to find out the values. So that is branch current or element currents. Our branch voltage are the voltage drops are any element voltage drops. So here we have 1, 2, 3 and 4 nodes we have. For small circuit we have the 4 nodes. Not principle of nodes. Principle of nodes is different, and this is the nodes, just nodes. Junctions, we can select junctions. Okay. So for this circuit we have the 4, 1, 2, 3, 4. So here one line will get, here one line will get, here one line will get, here one line will get. So if you observe, these 2 lines are same. So there is no element between, there is no current division, but which current we have here, same current we have here. Same, you will get the same answer. The same, we will get the same from which network. But the nodes is very, very important. Depending upon nodes, the remaining values. So which values we will find out, that values is depend. Okay. Coming to nodes, for this circuit we have 1, 2, 3, 4 nodes. So 4 nodes, 1, 2, 3, 4 nodes. And branches, we have 1, 2, 3, 4, 5, 6 branches. So 4 nodes, 6 branches for this circuit. Coming to theory, like a network topology, we have 1, 2, 3, 4, 5. 5 branches, 4 nodes. So branch value will change. Why this branch value will change means depending upon your sources. So if the current sources means the branch is open. So the branch value will be changed in circuit to graph. Okay guys, and for that graph we have different types we have, that is connected graph and unconnected graph. So if you compare both, so unconnected graphs means we have the nodes, we have the 4 nodes, but this branch and this branch in circuit, this branch and this branch, we have the suppose current sources. So current source means it's open, so you need to write the current source, but your node is not connected. So in general, this is my current source and this is also my current source, and remaining I have some resistor suppose. Okay, so for this I have the lines, but 1, 2, 3, 4 nodes. 4 nodes, but here I have a current source, here current source. This node is now open, so it's not connected graph. Coming to directed means we have the direction for each branch, and undirected means I don't have any direction. So this is different types of graphs we have, and in that graph we have subgraphs also, that is tree as well as co-tree. So in graph we have like different types. In that subgraphs also we have, that is tree and co-tree. Coming to tree, tree means suppose this is my graph. Okay, this is my tree. So this is my circuit to graph. Now for this graph, I will find out the sub graph, that is tree and co-tree. Coming to tree, we have some conditions. That is, so how many number of nodes we have? -1. So for this circuit, I have 4 nodes. So my trees value is n-1. That is 4 minus 1, 3 branches. So in that, how many branches we have? 1, 2, 3, 4, 5, 6 branches. In the 6 branches, 3 are your trees. 3 branches are your trees, and remaining 3 are your co-trees. So 3 branches are your trees, and remaining branches are your co-trees. So I will draw which tree I need to draw the trees. With 3 here I want to draw the trees like 3 branches. So which 3 branches I need to select? So for that any 3 you can select, but we have small condition. So these 3 branches connect to each node. And should not in closed loop. That is the condition. If you observe here, we have n number of original source we have. So 1, 2, 3, 4, 5 original graphs we have. So 5 are correct one. Okay. So here I have 3 are trees. So 1, 2, 3. So these are my trees from this original graph. These are the trees. If you observe the trees, so node 1 is connected with tree, node 2 connected with this tree, and node 4 also connected, and node 3 also connected. This is also correct one. And coming to here, so F branch, A branch, and C branch. 3 are my trees. So 1 node is connected with the tree, 2 node connected with this tree, and 3 node also connected with this tree, and 4th node also connected. And coming to this graph, these are same. 1, 2, 3 are connected each node, and should not in closed loop. If you observe here, so this is not closed loop. This is also not closed loop. So for each session, I don't have any closed loop, and each session I connected each node. If suppose from this graph I want to draw the tree, means here 1, 2, 3, 4 nodes. So A branch, if suppose I want to select A branch and D branch and C branch, remaining are my trees. If suppose, then it's not connected to this node. First condition is false, and second condition in a closed loop. So second condition also false. This is not your original graph. Okay. If suppose 1, A, B, and your F branch. So remaining are trees. These are trees. So A and D and F. So these 3 are my trees. Now not connected to this node. That's the first false condition false, and second condition is also in closed loop. The second false. So you need to satisfy 2 conditions. One is need to connect each node, and second condition is should not in closed loop. So remaining are your trees, co-trees. So trees are 3, and remaining 3 are your co-trees. So this is about the original graph, and original graph need direction also. Okay, direction also will require. So in that original graph, we have the directions, and trees and co-tree means we can find out the values about incident matrix, basic Tyshed matrix, and basic Cartesian matrix. We'll check it now. So incident matrix is number of nodes into branches. Number of nodes. So in the circuit we have the nodes as well as branches. So that matrix, incident matrix is the A matrix. That matrix is number of nodes. So n1, n2, n3, n4. So n how many number of nodes? Nodes into branches A, B, C, D, E, F branch. And basic Tyshed matrix is number of co-trees, your links. Even co-tree means here links. So number of co-trees into your branches. And Cartesian matrix is number of trees into your branches. Number of trees into. So depending upon trees, and here depending upon links. But we have some small changes. Here Incident matrix means number of nodes into branches. Okay, that is your matrix. Coming to tangent matrix, depending upon code trees. But this code tree here, we have small condition. We'll check it now. And for cut set matrix, depending on tree, but we have some cuts. We'll check it now. Okay, and here I want to write the matrix. So n into branches. So for A matrix, then I will get those values here. So for A matrix, B matrix, C matrix, we'll get only 1, 0 and minus 1s. 1, 0 and minus. Only 3 values in that matrix. So I will get like 1, I will get like 0, I will get a minus 1, we will check it now. Coming to A matrix, so I will write the matrix between nodes and branches. For this circuit, I have this graph. For this graph, this is my matrix. So if you observe here, nodes into branches. So a particular node, I will write the branches values. A particular node, I will write the branches value means. So here, A branch is outgoing, A branch is outgoing, C branch is incoming. So incomings are 1s, outgoings are minus 1s, and not connected branches are 0s. Simple. Okay, simple step. So incomings, for incomings are 1 and outgoings are minus 1 and not connected branches are 0s. For at node 1, for this graph, your node 1, A is outgoing, so minus 1, and C is incoming plus 1, and F is outgoing minus 1. Remaining is not connected, so 0. And coming to node 2, A is incoming plus 1 and B is outgoing. So B is also incoming plus 1 and D is outgoing minus 1. Remaining is not connected. If you observe the guys, same node 2 and node 3 and node 4. If you observe here, the summation of these branch currents equal to 0. For only A matrix. Only A matrix is possible. Okay, not to another matrix. Only A matrix, we add these branch currents, we'll get like 0. So we have the plus value, minus value, plus value, minus value for each branches. Okay. Suppose I don't have like this fourth node. If I want to find the fourth node, it's very simple. So we have the plus 1, so minus 1 and plus 1. So here the 0. Here are the 0, plus 1 and then minus 1. So plus 1 minus 1 already is there means we'll get the 0. Here we have the plus 1, 0, 0, but not minus 1. So we have minus 1 at fourth node. Okay. And here are the 0, minus 1. We don't have plus 1. So we have the plus 1 at fourth node. Again 0, 0, we have the 1, but we don't have minus 1. We have the minus 1. Again F branch, we have the minus 1, plus 1 we already said. So 0. We can write the fourth node value also. If you don't know the fourth node, you can write the fourth node value also. From circuit to matrix, we have the values. Am I right? Circuit to graph, graph to A matrix. Same thing you can redraw like a matrix, matrix to graph also. So how it is means here nodes then values. Am I right? Nodes then your A matrix. Coming to matrix to graph, branches then nodes. So coming to branches, branch A is connected between node 1 and node 2. So branch A is connected node 1 and node 2. And direction is minus 1 for node 1. So minus 1 for node 1. So outgoing from node 1. And branch B is connected 1 and 3. So 2 and 3. Branch B is connected 2 and 3. So 2 and 3 branch B connected, and direction towards 2. And branch C connected 1 and 4. So 1 and 4 I have the branch C, and the direction is towards 1. And branch D connected between 2 and 4. So 2 and 4 are branch D, and towards 4. 4 is plus, we have the towards 4. Coming to E also same as this. So between 3 and 4, and F 1 is 1 and 3. So if you know the matrix, you can write the graph also. You can draw the graph also. Okay, that is about A matrix. Coming to B matrix, so number of code trees, links. So if you know the links also, we can't write the matrix. Why means here we have some condition. So which condition means for this circuit we have the graph. From this graph we have the original graph. Here we have the 1, 2, 3 quotaries we have. So not only this type of original graph, we have 5 different types of original graphs. So in that 5 you can use any one you can use. Okay. So here the condition is I am using like only one quotary. I need to use only one quotary and go for a closed path. So I require one closed path. In that closed path, I need only one quotary, not more than one. That's the condition. That's it. In the closed path, how many branches we have? That branches values we need to write in matrix. And so we need to follow the quotary direction. And in the loop, that which direction we have. So same direction. If you have the reverse direction, we will have the -1. Same direction means we have the +1. Not connected branches, 0. Okay. Now, if suppose A is my quotary, so I need to use A value, A as quotary. If suppose A to 2, again 2 to 3, I can't. Why means it's also quotary. So 1 to 2 is okay. I'm using like A quotary, but 2 to 3 I can't go for closed path. Why means this is also one quotary. Now 2 to 4 I can go. So this is 3 and again 3, 4 to 1. If suppose you want to go to 4 to 3 means we have a 3, but again I need to close with 1. So again close with 1 means we have the F. So we can't go with the third node. So we have 1 node, 2 node and 4 node and again 1 node. So this is my closed path. So when I using like a is your quotary, this is my closed path. And which direction I need to follow? My direction is quotary direction. So that is A direction. A direction, this is my direction. Then this is your loop 1 value. Coming to one more loop. So one more loop means I have one more quotary, that is B quotary, and this is my loop. So 3 to 2, 2 to 4 and 4 to 3. This is my direction for B quotary. Coming to F quotary. So F quotary. So 1, 2, 3. That is my F is there. And 3 to 4. 4 to again 1. So this is my loop 3. And direction. This is my direction. So for each quotary I need to go for the closed loop. And in that closed loop I require only one quotary and direction. The quotary direction. So we have 3 quotaries means we have 3 loops. So 3 loops means your matrix. B matrix is L1, L2, L3 branches. A, B, C, D, E, F branches. And from loop 1 we have A, B, C values. So A value, D value and C value. And check the loop means A direction and B direction and C direction. A direction, D direction and C. So 3 are same. So this is also same direction, this is also same direction, this is also same direction. So we have the plus values remaining at zeros. Coming to loop 2, B direction. So B, D, E. So B, D and E. So B is so 3 to 2 and here D also 3 to 4 and he also same direction. So we don't have any minus values. Coming to F. So F, E, C, F, E and C. Now F direction is positive, Y means it's a quotary, and E direction it's a reverse. So F is positive but E is reverse. Reverse means we have the -1. For E we have the -1 remaining at zeros. And C is again same direction. So C is plus. So we have only E is minus. For this original graph, E is only minus, we have the minus value. Okay. Now we'll check it now. Here I have the original graph. Original graph's 2 loops. So using F, I have loop 1, using A, loop 2, using T, loop 3. So you can use any loop is as first loop. So no problem. Your matrix is change depending upon your loop directions. Okay, and here we have loop 1, loop 2, loop 3. For loop 1 we have F. For F only E is minus, so remaining, if you observe the direction also, F, E is reverse, C is same, and when you have the A in this loop, so everything is same direction. For D in this loop, everything is same direction, so we have the positive values. This is your B matrix. Coming to C matrix, we require cuts. So how many trees we have? So your C matrix depending upon trees and your branches. So your trees, for this tree I need to cut those trees. So how many trees we have? 3 trees. For this circuit, this is a graph. From this graph, this is a original graph. So for this original graph, I have trees. 3 trees we have. For this 3 trees, we need to cut a particular node, a particular junction. Now here we have C. Here we have C as well as D and E. So 3 are my trees. Now I need to cut a particular node once only. Once only. Remember, if suppose here node 1, node 2, node 3, my trees are connected. Node 4 also my tree is connected. Okay. For C, if suppose for C I want to cut here. Okay. Again, no need to cut here. For D, if I cut here, again no need to cut here. If I cut here, no need to cut here. So for one tree, cut at one particular node, any one node. Okay. When you cut the node, so suppose here C is there, so my C tree is cut at node 1. Okay, and C is connected at 4 also. So again, no need to cut at 4th node. Why means C is selected to node 1. Suppose here I want to go for the D. So here D I cut it to C like C2. This is D tree cut it at 4th node. Again, no need to cut here. Okay, here my C1 is there. So C branch, C tree is cutted here, and D tree is cutted here, and C like a E tree cutted here. Otherwise, here C, here D, here you can go for like E. So any place, 3 cuts. 3 trees means 3 cuts. C1, C branch cut here, D tree is cutted here, E tree is cutted here. Okay, any place you can cut. So there is no condition. Okay, but it's once only. So for C here, again no need to cut for C here. You need to cut for D here or E here. Okay, and for this circuit, for this graph, I selected like node 1, node 2 and node 3 for C tree and D tree and E tree. Now I required 1 and minus 1 and 0. Am I right? So not connected branches for 0. But 1 and minus 1 means depending upon direction. So which direction I need to consider there? A particular node. Incomings are outgoing. For A matrix, we have incoming is positive, outgoing is negative. For B matrix in a loop, so I take like coded direction. Coming to C matrix, so which tree cutted? So for node 1, I use a C tree. So incomings, C tree is incoming to node 1. So incomings are positive. So which value we have here at node 1, 2, 3 branches. So in that C is my tree. So C is incoming. So for that node 1, incomings are positive. Coming to node 2, I selected like D tree. Now D tree branch current is outgoing. So a particular 2 node I have like A, B and D. So D is my tree. So D is outgoing. So outgoings are positive. Coming to E, again incoming. So at node 3 I have the E tree. So E are incoming. So E is incoming means incoming currents are positive. Outgoing currents are negative. Now your matrix. So C1, C2, C3. C1 for C matrix and C2 for D matrix and C3 for E matrix. For C matrix, I selected node 1, here node 2 and node 3. At node 1, C is incoming. So incomings are positive. So A is outgoing, F is outgoing, C only incoming. C is incoming, A and F are minus. And coming to node 2, outgoings are positive. So at node 2, outgoings. So only D is outgoing and A and B are incoming, so minus. And node 3 like E branch is incoming and incomings are positive, so E is plus and F also plus and B is minus. So depending upon direction, which direction? Tree direction. A particular node, which tree we have, the tree direction, we need to follow the values. Here guys, this is about like cut set matrix. So, and we have one more topic, that is duality. Network duality. So same network, we can't solve means we'll go for the duality. So we have a big network. So I can't solve those current values, voltage values. So for that, I can go for like dual network. So that dual network means same network but reverse. If suppose I have like a voltage source. Voltage source means you can write like current source. If you have the current source, you can write like voltage source. If you have the resistor, you can go for the conductance. If the conductance, you can go for the like resistor. Inductor means capacitor means inductance, and open circuit means short circuit means open circuit. Series means parallel will get, parallel means series will get. We have the impedance means we will get the admittance means you will get the impedance. If you have the Kirchhoff's voltage law in that circuit means we will get like Kirchhoff's current law in that circuit. If you have the nodes, we will get converted into branches. If you have the branches, we can get to nodes. So same, it's like reverse. Okay, we'll check it on small circuit here. So 1, 2 voltage sources and the resistors I have. Now I will draw the dual network. So for this dual network, we have small conditions. So that is, first of all, we need to mention the loops. How many loops we have? So for this circuit, I have 3 loops. So loop 1, loop 2, loop 3. 3 loops. For 3 loops, convert into nodes. Loop means nodes. Okay, loop current means node voltage. So I have 3 loops means 3 nodes, and I require on reference node also. So that is VR equal to 0. So V1, V2 and V3. So 3 loops. Actually here we have I1, I2 and I3, but converted into nodes. Then small condition is, so here V1 voltage source we have. So V1 voltage, how many currents we have? Only one current, that is I1 current. So only one current means that value, which that element connected to reference node directly. So which element we have? Voltage source, that is connected to reference node only. But your voltage source convert to current source. So between 1 and 2 now, 1 and reference node, I have the voltage source that is converted to current source. Suppose 1, 2, 3 as well as VR node. So 1, 2, 3 and 4th node. Okay. So 1 and 4 I have now current source. So for this is completed. Now coming to R3. I have 2 currents. Am I right? So R3 I have 2 currents. I1 current as well as I2 current. So between 1 and 2 nodes I have R3. So R3 means we have like conductance G3. And coming to R1, between 1 and 3. So between 1 and 3 I have R3. So in R1 current we have I3 current and I1 current. So 2 current means between 1 and 3. So 1 and 3 I have like G1 conductance. And coming to R2 I have between 2 and 3. So R2 I have I3 current as well as I2 current. So 2 currents. 2 current means 2 nodes. 2 and 2 nodes. 2 and 3 nodes I have one G2L. And 4th node means we have only one current. So between R3 we have, so R4 we have only I3 current. So between 3rd node to your reference node. 3rd node to your reference node we have one G4. And last we have like a V2, which current we have only I2 current. V2 have only I2 current means 2 to reference node we have current. It's very simple, but we need to know which current we have, which node to I need to convert. So we have one more circuit here, small circuit, voltage source, inductors, resistors and capacitor and current source we have. Now 2 loops, so loop 1 and loop 2, 2 loops. So 2 nodes and 1 reference node. And coming to voltage source, we have only one current, I1 current. So between 1 to voltage source converted to current source. Voltage source converted to current source. So this voltage source is completed. Now coming to inductor, only one current I have. So that is I1 current. So in inductor converted capacitor between 1 and reference. So between 1 and reference node I have the capacitor. Coming to resistor we have like I2 current. I2 current means only one current I have. So resistor between node 2 to reference node converted to G conductance. Now here capacitor I have between 1 and 2, that is converted to inductor. So 1 and 2 I have the inductor. And we have last one, I source current, and here we have only one current, that is loop 2 current. Loop 2 current means 2 to reference node we have the voltage. I have one more circuit. So voltage sources, capacitor, resistor, inductors. So in number of we have. Okay. Now observe. For inductor we have only one current. Voltage source we have only one current. And resistor we have only one current. So 1, 2, 3 elements connected to one node to reference. So one node to reference I have 1, 2, 3 elements. So voltage is current, inductor is capacitor, resistor is conductance. And loop 2. So 1 and 2 I have capacitor converted to inductor. Okay. And coming to loop 2 we have 4 is I have only one current, and 5 also have only one current. So 4 and 5. And 2 and 3 I have one current source. So 2 and 3 I have voltage source. And at 3 I have again 1, 2, 3 elements are having only one current, that is I3 current. So third node to 1, 2, 3 elements. So remember guys, when we have the series, suppose R1, R2 as well as R3 and one voltage source. So R1, R2 and R3 and we have the voltage source. Then replace with your dual network means only one loop. So only one loop means we have the like only one node. So only one node and we have only one reference node. So one and reference node we have elements. So R is first voltage. Voltage is we have only one current source. Voltage source converted to current source. Resistor, so parallel with resistor, and R2 again parallel with R2, R3. So your series network converted to parallel network. So R1 having only one current, R2 having only one current, R3 also having only one current. So between 1 and reference node I have the like G1, G2, G3, and voltage source series with converted to current source. So series network we have like parallel. If suppose I have like parallel network. So current source 1, 2 and 3. So how many loops we have? So we have like so here we have loop 1, loop 2, loop 3. So node 1, node 2, node 3, and here we have the reference node VR. So node 1, node 2, node 3 and VR. Okay, your current source having which current? Only one current, that is loop 1 current. So 1, 2, 3. So loop 1 to your voltage source converted to current source. So current source converted to voltage source. And this R1, suppose R1, R2, R3. So this R1 between 1 and 2. So 1 and 2 I have like G1. And R2 between 2 and 3. 2 and 3 I have like. And last one we have only one current, that is a loop 3 current. So connected to reference node. If you observe in series, so parallel network connected to series network connected to parallel. Any manner. Okay, that is the duality of those networks. Okay guys, so this is about the two-port network as well as graph theory. If any queries on this two-port network and graph theory, comment in comment box. Okay, thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.